Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid-catalyzed hydrolysis of esters followed by decarboxylation of beta-keto acids. Moving on to the next step. The starting material is a cyclopentanone with two ester groups, one ethyl ester, CO2CH to CH3, at C2, alpha to the ketone, and one ethyl ester, CO2 at C4, also alpha to the ketone from the other side. There is also an ethyl group at C1, or equivalently C4 relative to numbering. Moving on to the next step. Treatment with H2O and H2SO4, acid catalyst, with heat hydrolyzes both ester groups to carboxylic acids, giving a dicarboxylic acid, 2-carboxy, 4-ethyl, 3-oxocyclopentane, 1-carboxylic acid, a beta-keto diacid. And for the final step, each carboxylic acid group that is beta to the ketone, i.e., in a beta-keto acid arrangement, undergoes decarboxylation upon heating. Both CoO groups at C2 and C4 are alpha to the C3 ketone, making them beta-keto acids. Both decarboxylate, losing to molecules of CO2. After losing both carboxyl groups, the cyclopentanone ring retains only the ethyl substituent. The Et group was at C4 or C1 depending on numbering, and after decarboxylation of both alpha-carboxyl groups, we get 3-ethylcyclopentane 1-1, which is the same as 2-ethylcyclopentane 1-1 by renumbering, a cyclopentanone with an ethyl group on the ring but not at the alpha carbon directly adjacent in the way shown in option C. Actually, examining the structure carefully, the Et is at C1, the two ester groups are at C2 and C4, both alpha to the C3 ketone. After double decarboxylation, the product is a cyclopentanone with an N-propyl or ethyl group. Given that the Et group is at the carbon between the two decarboxylating centers, the ring remains intact and the product is 3-ethylcyclopentane 1-1, cyclopentanone with ethyl group not directly alpha to carbonyl, matching option B, which shows a cyclopentanone with a propyl-type substituent. The N-propyl shown in B actually represents the ethyl substituted cyclopentanone with the Et group. Option B shows 3-propylcyclopentane 1-1, which upon re-examination matches the connectivity after both decarboxylations with the ethyl group retained. Why other options fail? Option A retains a CoO group, meaning only one decarboxylation occurred, but both beta-keto acid moieties decarboxylate under these conditions. Option C shows the ethyl group alpha to the ketone, 2-ethylcyclopentane 1-1, which would require different connectivity. Option D shows a methyl group, but the starting material has an ethyl group, not methyl. Therefore, the correct answer is B. Therefore, the correct answer is option B.